Okay, I want to look at sector area and arc length. So if you can imagine maybe a big sprinkler here, and it's got a range of 8 meters, and it's set so it covers 120 degrees. So it doesn't go full circle, it just covers that. So arc length is just a proportion of the circumference. Sector area is a proportion of the area. So if I'm finding the arc length, it's going to be based on the circumference equals pi times diameter. That doesn't go away. So in this case, I would have pi times 16 because the radius is 8. So I could put over here, so radius equals 8 meters, therefore the diameter equals 16. So those two are key figures. The other key figure is the 120. So I do that, and what I do as well is I establish a fraction, because I don't want the whole thing. If I go pi times 16, I'll get a number that's too big. If I just go pi times 16, at the moment it would be 50 meters, 50.3. So I know a full circle is always 360 degrees, so I put that in my bottom line, and I want 120 of that. Now, if I can, I want to simplify that, and that becomes 1/3, and times or of, and that. So 1/3 of the pi times 16. I put that in my calculator. Because it's 1/3, I could just leave that to the end and go divide by 3. If I didn't know the simplified version, I can put it in top line divided by bottom line times pi times 16. So I could do this time. 1 divided by 3 times pi times 16. And I get 16.8, and that is meters. And then when I go to area, the same principle applies really. So I know that area of a circle is simply pi times a radius squared. So that's going to be part of my answer, pi times radius squared, which is 8 squared. So we're going to have area not of the sector equals, so we're going to have the fraction at the start. It's the same fraction, so arguably I could simplify it straight away. 1/3 times pi times 8 squared. This is just the full circle if it rotated fully around and we wanted the entire area, and we don't want that. So in a calculator you can do this various ways, but this is one way that will work regardless of whether you've simplified the fraction or not. Top line divided by bottom line to get the fraction in, times pi times 8 squared. And that will give us 1 divided by 3 times pi times 8 squared. Gives us 67.0, and that is meters squared because it's an area. So for arc length, we're finding the circumference, but then just taking a fraction below 1 of that arc length, a proportion of that. For area, sector area, we're doing exactly the same thing. We're still using the area of a circle formula, but we just start with a fraction at the start. Okay?